All right, let's begin. Empezamos. Can you hear me? ¿Me escuchan? Okay, can you see my slides? ¿Pueden ver mis diapositivas?
Sí.
Excelente. All right, so hi everyone. Good afternoon or good morning. I'm Diego Souza from NINPE, Brazil, and this is the third teleconference of the Regional Data Processing and Visualization Task Force. Hola a todos, buenas tardes o buenos días. Yo soy Diego Souza del INPE de Brasil y esta es la tercera teleconferencia del Grupo de Trabajo Regional de Procesamiento y Visualización de Datos. The first two meetings were conducted entirely in Spanish and Portuguese because we only had Spanish and Portuguese-speaking participants. But today we have some English-speaking colleagues joining us. So today we will have a mix of languages and we will try to translate the key points. En nuestras dos primeras reuniones fueron totalmente en español y un poquito de portugués, pero hoy vamos a tener algunos colegas que hablan inglés y entonces vamos a intentar traducir los puntos clave en la discusión. If you have any questions during the presentations, you may send your question to the chat and we will try to translate your questions after the presentations. Si tienen alguna pregunta durante las presentaciones, pueden enviarlas directamente a la ventana de chat y vamos a intentar traducirlas después de las presentaciones. We have some participants that are attending for the first time, so it's always good to provide a very quick summary on what we already did. On the first teleconference, we introduced the WMO Satellite Data Requirements Coordination Group, which originated this task force. We presented why this task force has been created. We also suggested some possible working arrangements for this group. And after that, our colleagues presented the interfaces they are using in their institutions. And then we finished it with an open discussion and defined some draft actions. Tenemos hoy algunos participantes que están en la reunión por primera vez, entonces es siempre bueno tener un resumen muy rápido de lo que ya hicimos. Entonces, en nuestra primera teleconferencia introducimos el grupo de coordinación de requerimiento de datos satelitales que originó este grupo de trabajo, el por qué este grupo fue creado y también sugerimos cómo puede ser la dinámica de trabajo del grupo. Y luego vimos varias presentaciones de nuestros colegas con las interfaces de visualización de datos que usan en sus instituciones. Then, in our second teleconference a month ago, we had a couple of presentations from our colleagues from Brazil and Chile. The first one presented by my colleague Douglas from NINPE regarding the DSAT visualization interface. And the second presentation from Miguel Arturo and the PUCV team from Chile, they presented the GeoScore, which is another great open source solution. So they presented, both of them presented the features of these tools, the open source solutions that they have used to develop them, both at the back end and front end, as well as the details of how the data is being processed by these tools. En nuestra segunda teleconferencia tuvimos un par de presentaciones de nuestros colegas de Brasil y de Chile. La primera presentada por Douglas del INPE sobre la interfaz de visualización del DSAT y la segunda de Miguel Arturo y los colegas de Chile sobre el GeoScore. Y ambos presentaron las funciones y las herramientas de código abierto utilizadas tanto en el backend como en el frontend, así como detalles de cómo se procesan los datos. And remembering the goals of this task force, first to facilitate the generation and utilization of satellite products, joining efforts from developers from different member countries. And second, to encourage the usage, creation and distribution of open source solutions. Recordando los objetivos de este grupo de trabajo, que primero es facilitar la generación y el uso de productos satelitales, uniendo esfuerzos de desarrolladores de diferentes países. Y segundo, fomentar el uso, la creación y distribución de herramientas de código abierto. And this is basically what we are going to see today again. After introducing the participants, we will have a presentation on Pytroll and SatPy, which is a great open source project. And here I would like to thank Martin and David for the availability for this presentation. We really appreciate that, and this is going to be very useful for us. And after that, we will see some aspects of the GLM gridded products processing, as we have agreed to work on during the first teleconference. And then we'll finish with an open discussion. En la agenda de hoy, después de presentar los participantes, tendremos una presentación sobre Pytroll y SatPy, que es un proyecto de código abierto muy interesante y muy útil para la comunidad. Y acá me gustaría agradecer a Martin y a David por la disponibilidad para hacer esta presentación. Y luego vamos a ver algunos aspectos de los productos GLM que acordamos trabajar durante la primera reunión. Y vamos a terminar con una discusión abierta. All right, let's introduce the participants for this call. We have 16 participants. I'm seeing Camilo Barahona from Chile. Veo Camilo Barahona de Chile. Hola, Camilo. ¿Me escuchas? Está con su micrófono deshabilitado, sin problemas. I'm seeing David. Hello, David. Can you hear us?
Yes, hello.
Hi. Thanks for joining. We also have Edison Cruz from Ecuador. Hola, Edison. ¿Qué tal? ¿Nos escuchas? También, we also have Gustavo Quesada from Chile. Hola, Gustavo.
Hola, Diego, ¿cómo estás?
Muy bien. Gracias. We have Herman Opaso from Chile. Welcome, Herman. Hola, Herman.
Hola, Diego. ¿Cómo está? ¿Todo bien por acá?
Thank you. Gracias. I'm seeing João Huaman from Peru. Hola, João. ¿Nos escuchas? ¿Puedes abrir tu micrófono? Si no, sin problemas. Está escribiendo. He's writing on the chat. Hi, João. No problem. He's without microphone today. Yep. No problem. We also have Jorge Bravo from Mexico. Hola, Jorge. ¿Nos escuchas? Jorge.
Y venía con una salsita muy rica. Gracias. Provecho.
Bueno, creo que Jorge también está con su micrófono apagado. We also have Luciano Vidal from the Argentinian National Meteorological Service. He's without microphone. He will write on the chat. Welcome, Luciano. Bienvenido, Ucho. Muchas gracias.
Hola, ¿qué tal? ¿Qué tal? Buenas tardes a todos y hello, everyone.
We also have Luis Marín. Hola, Luis. ¿Nos escuchas?
Hola, Diego, sí. Saludos desde Chile.
Saludos. Muchas gracias por la participación. We also have Mario Guerra from Guatemala, I think. Hola. Hello, Mario. Hola, Mario. ¿Me escuchas? ¿Estás ahí? Ok. Puedes escribir en el chat sin problemas. We also have Marta Caneo from Chile. Hola, Marta. ¿Me escuchas bien?
Hola, sí, gusto saludarte. Acá estoy con algunos colegas nuevos que tenemos en la oficina.
¿Cómo se llama?
Yo soy Roberto Pérez, de Chile.
Ok.
Cristóbal Aguilera, de Chile.
Bienvenidos.
Son
Gracias.
nuevos integrantes de nuestra oficina, recién llegados, así que estamos participando con ellos.
Excelente. Muchas gracias por la participación. Thank you very much for joining us today. We also have Martin Rugna. Hola, Martin. ¿Todo bien?
Buenas tardes, ¿qué tal?
Buenas tardes.
Good evening a todos.
Hello. Miguel Fernández, from Chile. Hola, Miguel.
Hola, Diego, ¿cómo estás?
Muy bien, gracias. Gracias
Saludos a todos por ahí.
por la participación. Tenemos también, we also have Raúl Parra. ¿Nos escuchas, Raúl?
Hola, ¿qué tal, Diego? Saludos de Ecuador.
Saludos, Raúl is from Ecuador. And we also have Richard Ribeiro from Brazil. Oi, Richard, tá escutando?
Opa, boa tarde, perfeitamente, Diego. Obrigado.
Obrigado pela participação. Thank you for joining. We have Sandra from Ecuador. Hola, Sandra. ¿Escuchas bien? Puede escribir en el chat sin problemas. And we have Marcial Garbanzo, the other co-chair of this group. Welcome, Marcial. Hola, Marcial, ¿estás ahí? Marcial iba a participar de otra reunión en paralelo. No sé si está disponible. Marcial was attending a meeting in parallel, so he's probably not available now. And Martin, our guest for today. Welcome, Martin.
Hola, gracias.
Okay. These are some of the task force participants, and let's begin. Now I will hand it over to Martin and David for their presentation about Pytroll and SatPy. Muy bien, gracias a todos. Ahora le pasamos la palabra a Martin y a David, que van a presentar la herramienta Pytroll SatPy. Go ahead, Martin, you may share your screen. I will stop sharing mine. If you have any questions, please send your questions in the chat window. Si tienen alguna pregunta sobre la herramienta, pueden enviar vuestras preguntas en el chat o después de la pregunta levantar la mano. Y entonces vamos a abrir los micrófonos. Muchas gracias. Go ahead, Martin. Thank you.
Thank you very much. So I'm sorry I didn't prepare this in Spanish. Lo siento, no he preparado esto en español, pero si tienes preguntas, entiendo un poquito. So today I'm going to talk about Pytroll, which is an open source Python framework for Earth observation satellite data. The plan is to have this presentation in two parts. The first part will be a regular presentation with some slides. And the second part will be a short demonstration in a Jupyter notebook. Diego, do you want me to take breaks so that you can translate, or?
No, please go ahead. And then if they have any questions, they will send in the chat, right?
Okay.
You may go ahead. Okay.
So a little bit about me. I work at the Swedish Meteorological and Hydrological Institute. And I've done so for almost 15 years now. And I'm a software engineer. Recently, I've been appointed as research leader on the topic of software methods for meteorological applications. So, and I've been working for Pytroll almost as long as I worked at SMHI, and I'm going to present what Pytroll is now. So Pytroll is a collection of free and open source software Python packages for processing Earth observation satellite data. So there are many things that Pytroll can do. One of them is project or imagery generation. And that's what I'm going to focus on today. Of course, we also have other things that Pytroll can do, and you're free to look at the website if you want to know more about it. So satellite data, as you probably know, what I'm going to talk about is mostly data from imagers. So in imagers, each channel of the imager instrument is covering a narrow frequency band. And we have different frequencies that can expose different features that we're interested in looking at. So in order to look at these features, we can look at a single channel.
¿Qué?
Por favor, pueden deshabilitar vuestros micrófonos. Please mute your microphones. Thank you.
Yeah, so you can look at a single channel to see some more features. Another way of looking at some meteorological features in satellite data is to combine different channels into the red, green, and blue parts of an image. of a color image. So it looks like this when you have the channels assigned. But you can also do more complicated stuff like differences of channels and things like this. So you can combine the channels for more features. By the way, all the satellite imagery that you will see in this presentation have been generated with SatPy. So nothing comes from the outside.
Habla, Rodrigo.
So,
Alejandro, por favor, puedes deshabilitar tu micrófono. Gracias.
So the way SatPy is done is that we have tried to have a common interface for all the satellite data, because we believe that most of the satellite data, at least when it comes to imagers, is very similar independently of the instrument. So we believe they should have a common interface in Python. And the data format should not be an issue. We work with level 1 data as input. And as you probably know, there are many different formats. And we try to abstract this totally from the user. SatPy is easy to set up and to start working with. All the configurations that need to start are already included in the package. So it's you don't need anything special. You don't need to configure anything special. And it's easily expandable and configurable. We do have a system of plugins, and we do have configuration files that are easy to edit. So, and that's how you can expand it. And we believe that the metadata of the satellite data should be available at all times. So in summary, SatPy is a high-level processing library for satellite data, and it works both with geostationary data, low Earth orbiting satellites, but also high elliptical orbit satellites. And you can resample the data to any Approach 4 projection. I will talk a little bit more about this later. So reading, processing, and saving satellite data, we support more than 90 different satellite data formats, and we support remote files for some of the formats. And we have many built-in composites and corrections. We can save to popular image formats or GIS formats or SDR, for example. And it's easy to expand. So that's just a small comic strip about the situation of standards. And this is a reason why we are really trying to not invent our own format. So when we need to write, for example, to NetSDF, we follow the climate and forecast conventions as much as possible. So a small code example from SatPy. If you are familiar with Python, you will recognize this as something that is very simple to set up and start. The first 2 lines are about importing the necessary libraries. And then we have the third line is about setting the list of files that we're going to read from. In this case, it's going to be VIIRS data from the Suomi NPP satellite. And then we create this scene object where we provide the name of the reader and the name and the list of files. And from there, we can load the true color image, for example, the true color composite, resample it to a given area, and then save the data set on the disk. And what you will get is something like the image on the right. Other things that you can do with SatPy is that you can load also individual channels for the instruments, either by name, like for example this M15, or by wavelengths here in micron, so 0.6 micron. Showing a channel on the screen is as simple as doing scn.show, so scene.show, with the name of the channel that you want to show on screen. And you can do arithmetics on the channels because they are just like regular arrays. So I talked about resampling here in the example, and I just want to underline again that it works both from unprojected data or from gridded data that you might have. And it is using Proj in the background, and Proj has more than 130 different projections available. So you can project to any of those projections that you are interested in. Here we have a few examples of different projections. Another thing that we use in SatPy, which is a library which is underneath SatPy, so that we use there, is called Xarray. For those of you who are working with Python in science, you're probably aware of Xarray because it's becoming more and more popular. And the idea is that the dimensions are labeled, and then the metadata is also provided for the data. So it's exactly what we want for SatPy, and that's why we started using it. And as an example, if you look at the display that you get when you want to show just one channel in the prompt, you can see that this is an Xarray data array, and then you have the coordinates that are defined here as X and Y, and then you have different attributes. I don't show all the attributes here, but there are usually more than these available. Some composites that are provided with SatPy, just some examples. So we have the true color that I showed earlier on the top right. On the left, you have a composite that we call the snow age, which is supposed to give us the state of the snow on the ground. And in the middle, you have a composite called day natural color, and which is something that is very popular in Europe because on the Meteosat satellite series, we still don't have the possibility to do true colors. And then on the bottom right, we have another composite, which is called ash, and is for monitoring the ash clouds when they come from volcanic eruptions, for example. So, as you probably know, the satellite data is becoming bigger and bigger every year. So it's quite difficult to get things running fast and smooth. And that's why in SatPy we needed to take some action in order to make this better. So in order to address the scalability problem, as you can, as I said, too much data, and it can take too long to process for interactivity because of the high resolution. So that's an example of Himawari 8. Solution is to implement out-of-memory processing so that you don't put all the data at once inside the memory of the computer, but rather you take small bits at a time. And those small bits, you can actually work with them in a multi-core, multi-processing or distributed processing fashion. And for that, we use a library which is called Dask. So Dask is also a Python library, which we make use of in SatPy. As you can see, that's an example of an animation of something called a Dask graph. So Dask is creating a graph when you call different commands. The commands are very similar to NumPy. So if you're familiar with NumPy for processing scientific data, Dask is very, very similar. The main difference is that the processing is lazy. So when you do, for example, A plus B with Dask arrays, it will actually create an object called a Dask array, but it will not be populated with actual data until you ask it to do so. And that allows to do different things. So as I said, the processing is lazy. It is out of memory, so it takes just a few parts of the data if you tell it to do so. And it can also do distributed processing, either on one computer or on several computers or a cluster if you have access to it. Another thing that is really nice with Dask is that you have these windows for diagnostics. Here you have an example of this. So on the top, you can see the different tasks that are being run in real time by Dask. And then you can see on the second part the CPU and memory consumption and the cache size on the bottom. And in order to address the fact that the data is bigger, we try to use the tools that are as efficient as possible. So for the Python scientific stack, we use NumPy and SciPy when it's needed. For resampling, we have a package called PyResample that we maintain and develop. And with that, PyKD3, which is also something which is part of the Pytroll project. On the right, you have an example of the performance of the PyKD3. So if you look at SciPy, it takes, for example, 100 seconds. And for that, another library called liban, which is available, which is a C library, would take 50 seconds. But with the Pytroll implementation in PyKD3, we go down to 30 or 25 seconds. Other packages that we have in Pytroll, which are also quite optimized, we have the Python geotypons for interpolation of navigation data. We have the spectral domain computations in PySpectral, and we have orbital and space computation in PyOrbital. These are just a few of the packages that we have available, and there are more than these. Any questions so far?
¿Vosotros tienen alguna pregunta que desean hacer hasta lo que ha sido presentado hasta el momento? Si tienen, pueden decir o abrir vuestros micrófonos. Si no, bueno, después de la presentación hacemos las preguntas. No creo que tenemos preguntas por ahora. So Martin, you may go ahead, and after the presentation, yes, we ask for more questions. Okay, thank you.
Thank you. So a little bit about development and community. So the background for this project is that we started as small teams. At the very beginning, it was just Sweden and Denmark. And we were 2 in Sweden working with satellite data, and there were 3 in Denmark. So, and we realized that we needed to work together if we wanted to be able to do something bigger than what we had. And we realized that we had the same needs, and we were using the same tools. In this regards, it was Python. And so we decided to go for some principles that the software should be kept modular. So that's why there are many Pytroll packages, different small modules, because maybe you don't want to use everything. So it's easier this way. And we want it to be reusable. So that means a certain standard on code quality and the availability of the code at all times. And it should be maintainable so that it should be easy to progress. And we should keep it simple and stupid. So we try to avoid making any decisions instead of the user. So we leave the user make the big decisions. And it should be especially easy to use. We decided to have it open from the start. So most of the Pytroll modules are in the GPL license, version 3. The code is open and free. You can access it at all times on GitHub. And everyone is encouraged to participate. So we have a community at the moment. And Pytroll is used operationally in many institutes across Europe, North and South America, as far as we know, probably more. But since it's an open source project, not everyone is telling us that they're using it. We have an active community and we don't have any funding. And we have quite many contributions, I think. And we have a memorandum of understanding between some of the institutes in Europe to make sure that Pytroll goes on and continues to grow. Pytroll is also used in research because of the high quality of the data processing. It is reproducible, it is reliable, and it is traceable. And we have some colleagues who are using Pytroll for research successfully, so that's very nice. Our software, the different modules, at least some of them are each version is available in Zenodo with a DOI, so you can cite the version of the software that you're using in your article. And that's it for the first part. So if you want to get in touch with us, we like to use Slack quite a lot to discuss. So feel free to join the Pytroll Slack. We also have an organization on GitHub called Pytroll, so you can look it up there, and we have the different repositories for the code. We also have a mailing list, which is the Pytroll at Google Groups. And last but not least, we also have a Twitter account where we sometimes post information or images. So thank you for this.
Thanks, Martin. If you want, you may proceed with the demonstration, and after that, we will ask the participants which one of them already uses SetPy. I know that there are some here on this meeting from Mexico and other countries that already use SetPy.
Yes.
So let's check your demonstration, and then we will proceed with the discussions.
Okay, very good. So here is just a small Jupyter notebook. I hope you can see it correctly. So I'm going to work with some data that you probably are familiar with. It's the ABI data from the GOES satellites. So the first thing that I have here, the first cell that you can see, is that we are going to download some data. I actually commented out the actual command for downloading the data because I already have it on my computer, because it takes maybe 4 or 5 minutes. I didn't want to take the time in this presentation. Yes, otherwise this get Hurricane Florence ABI would just download the data on your computer. So I just set the base directory where I have my data. And then the first thing that I do is I create the scene object as I showed before. So creating a scene object should not take a lot of time because it's just looking for the files and then getting ready to process the data. And from this scene object, we have a few methods that are usable and that you can do things with. So the first one that I want to show is this available dataset names. So this available dataset names will show you the name of the channels that you have at your disposition. So if you want to look at the data of the different channels, you can just pick one of these. And the way that you do this is just that you call the load method of the scene object like this, and then it will just show you then that this is an X-array data array here, and then this data array contains it tells you how much space it takes also in memory, the shape of the array, and then other information regarding the Dask array. And then you have the X-array information with the coordinates that you can collapse, or you can actually go further, look at the attributes. So as I showed before, we have different kind of attributes, for example, orbital parameters, standard name, and then the units, the resolution, and so on and so forth. So this is very useful if you want to know exactly what you have loaded. And this is, of course, accessible programmatically if you want to do some filtering or things like this. So the next thing that we can do with the scene object is to try to show the data that we have loaded. So in this example, I will show the C10 that I've channel that I've shown before. And as you can see here, we get the image. It's an infrared image. So the darker parts are colder and the whiter parts are warmer. And this displays directly in the Jupyter notebook here because it's an interactive platform. But if you're running in the terminal, for example, usually this will open another window and show you the image in the other window. So very, very simple to look at the data. I showed the attributes before here, and as you can see, there's something called the area. And the area is quite important because it gives you the navigation and the position of the satellite data in space, or rather on the Earth. And as you can see, there are different things in this area object. One of them is the projection, so it tells you that this is actually the GEOS projection, so the geostationary projection. So it means that we are still in satellite projection here. And then it also tells you how much it extends on different directions. So we have the lower left and the upper right corner here. Once you have this this channel, you can do other things. So yeah, I showed the channels, but there's other things that we can load. For example, you can look at the available composites. So this gives you the name of the built-in composites that you have in SatPy for this satellite data. Of course, you can also add your own composites in configuration files. It should be pretty easy. But for now, I'm going to go with the built-in ones because in the interest of time. So for example, here, let's say that we want to load a true color image. As you may know, the true color image is trying to get the red, the green, and the blue channels from the satellite in order to create something that would look like an image that you would see with the eyes if you were in space. But here, SatPy is telling you that the following data sets were not created and might require resampling. And the problem with the ABI data is that different channels have different resolutions. So I think it's the CO2 channel that has a high resolution, and because of that, you cannot really blend it with the other arrays, which are in 1 kilometer resolution. So in order to address that, we resample the data very quickly. So we use this special resampler, which is called native, and the native will just try to adjust the size of the array so that they're the same resolution. So it's not doing any clever resampling as the other routines that we have in SatPy. It's just trying to make it easy. And then, so we tell it to resample the data. It tells you what it's going to look like. As before, with the size of the array and the attributes and the coordinates. And then you can show it on the screen. And as you can see, the showing takes a little bit of time. And that is because the array in the background is lazy. So until now, it hasn't done anything. And it's just when I'm telling it to show the picture on screen that it's actually starting to do the computation. So that's why the last steps always takes a little bit more time. So this image I just created now from the data I had on my laptop. And it, as you can see, it goes pretty fast. That's quite nice. So something that we could say is that actually we just don't want one image. Maybe we want to create an animation. So if we want to create an animation, we can use another module of SatPy, which is called the multiscene. And here it takes 4 lines to create an animation. So you create this multiscene object. You say which files that you're going to get the data from, which reader you use. And then you say that you want to have the true color for the animation. Just as before, we do the resampling with the native because of the problem with the different resolutions in different channels. And we save the animation on disk. So I will trigger this now. It will take maybe 1 minute or something like this because, of course, it needs to create about 20 different frames. So it will take a little bit of time. And here we're just processing, I think, 20 frames, so or 10 frames. So it will just take 2 seconds in the end. Of course, I have more data on my computer. I could make it longer, but this is just for illustration purposes. So I will not go further than two seconds for that. So while we wait for this,
we have a question, Martin.
Yes, very good.
It's a question from João from Peru, the Peruvian National Weather Service. He said, I see that we can generate RGB composites with a single command. I think it's the scene load, right?
Yes.
And you select the RGB.
Yes.
João would like to know if it is possible to adjust the RGB thresholds and use it on the recipes. You know what I mean? Those thresholds, minimum and maximum values for each R, G, and B components. If it is possible to adjust these without entering the sub routines of the used by SatPy, if there is a possibility to adjust those easily.
Yes, I understand totally, and this is absolutely possible. This is usually something that you would do in the configuration files. So I can give the example of how we do here at our institute. So the way that we have the composites to generate them in the way that our customers want. We have our own configuration files, which we put in a given directory. And then the directory is just being used then when we process the data. And there it takes over the built-in settings. So whatever I put in my directory will take precedence, and we will use that. And there you can not only add new composites, but you can also adjust the existing ones. For example, the true color, if you want to change the thresholds. That's totally possible.
Excelente. Entonces, João comentó que es totalmente posible ajustar los limiares, y esto es hecho con los que, como se llaman archivos de configuración. Lo que ellos hacen es crear sus propios archivos de configuración para los compuestos RGB, y en estos archivos se determinan los limiares. João has another question. When you are creating the RGBs, sometimes you use bands with different resolution, spatial resolution. He would like to know if it is possible to select the final image resolution for the lower or the higher, So he would like to know if that is possible to select using
Yes, it is possible. So as you can see, for example, here we're using this resample command. And we just say that we're going to put everything at the same resolution, and we don't specify what resolution. But you have two commands here that you can add to select either the high resolution or the low resolution of the two different channels. So it is possible.
Ok, entonces es posible elegir la resolución de la imagen final con el comando resample. Si no especificas nada, genera con la resolución que tiene por defecto, pero hay parámetros que puedes especificar si quieres la máxima o la mínima resolución de las bandas que están en las composiciones RGB. Gustavo Quezada from Chile is asking where he can make the adjustments of the region, of the domain, of the image,
Yes. Yes, of course. I will come to that a little bit later in the presentation, but I can already say it's the same principle. So it's also a configuration file. So you can add your own configuration file with the different areas, and then you can add your own areas that you're going to resample to.
Entonces, comentó Martín que va a comentar sobre eso más adelante, Gustavo, pero comentó que es lo mismo que la resolución. En el archivo de configuración tienes los campos que puedes especificar las regiones de interés. Thank you.
Can I add, this is David, you can also create that area in Python, and there is also a crop method on the scene object, which lets you specify a bounding box in latitude, longitude, or XY meters.
Okay, so David comentó que también puedes cambiar la región directamente en el comando Python que utiliza SatPy y puedes especificar los parámetros de las coordenadas que deseas directamente en el comando. Thanks for your comments, Gustavo and what's his
Yes.
name?
Thank you very much.
Thank you very much.
As so during the questions, this was generated, and as you can see now, we have a video available. So I can click play to see the to see it play. It might not be possible for you to see it so well, but it's actually working, and it's because it's small time steps. It doesn't move a lot. But yeah, so you can have the video interactively, but actually you have the file. Now I have the file on my hard drive, so I can use it in other contexts. So now I have showed how to use the data that I have on my computer. But I'm going to show now that it's also possible to use data that is available in the cloud. Yes, I will provide a notebook later. No problem. I'll send it to Diego and he'll forward it to you. So the data that we have in the cloud, for example, I'm taking the Amazon Web Services. As you probably know, they have the Go 16, 17, and 18 data available there. And you can actually use SatPy and get the data directly from S3. That are available in the S3 bucket. And then it's going to use them as files, as input files in the SatPy scene object. So we needed to create those FS file instances for this. So it's not as easy as things that you have on the hard drive, but it's pretty simple. And this allows you then to directly use something that is in S3. So it takes a little time now because it's actually downloading the data. But now we're done. And then exactly as we did before, I'm going to do the load. In this case, I'm not going to use Truecaller. I'm going to use another composite, which is called CloudPhase, for example. And I'm going to do exactly the same as before, resample it to the same resolution, and then show it on screen. And then as you can see, this takes just a few seconds also because it is computing. So here I have my image that I created. And then talking about resampling. So we had this question before about your own area. So as David said, you can, the first thing that you can do if you're just interested in cropping the data, then you can just use the crop command and it will just cut out whatever you are interested in. But sometimes you want to change the projection also. And for that, you can use the resample command again, but this time you just provide the name of the area that you want to resample to. And as I said before, this area is defined in my configuration file. So you go in the configuration file and you can add your own area. And then you can just use the name here. And it will use the name to find out which area it is. And then it will use that to resample. So here I'm going to resample to this area, which is called MOL. And MOL is actually a global mole-wide projection. So it will show the entire globe. And I use this reduce data equals to false because I want to speed it up a little bit. I know the full data fits in this region, so I don't need to cut it out before. And then I plot it. And you will see it takes just a couple of seconds. And you will get a big image, a big white image with some data in the middle. So it's not very interesting because you don't really know where it is. And that's why I'm going to show you now here that you can also call the show method and you can provide the coastline. So if you have coastlines available, you can have a look on the Pytroll, on the PyCoast website, and it will tell you how to get those coastlines. I'm here in echo. All right.
Please mute your microphones.
So this show method, you can actually use the overlay, and the overlay would add the coastline on your image. So just in the same manner as I did before, I now have the different coastlines plotted also. So I can see that the data was actually of the coast of the Caribbeans. So another thing that might be worth noting for the resampling is that once you resample, the area attribute in your data is changing, of course, because it reflects now the new area that you have for your data. So you can start working from that instead.
Martin, I have a question.
Yes?
Can I load two separate scenes, for example, for goes west and goes east, and then use both in a single resampling so I have a mosaic?
Yes. I think this is possible with the multi-scene object, as I showed before. So in the same manner as you use the multi-scene for an animation, you have also the possibility, instead of doing an animation, to overlay the different images together.
Okay.
So the last thing I'm going to talk about today is Cartopy. I suppose some of you are using Cartopy to plot the data. And I'm just going to show you that it's possible to plot channels in Cartopy. So here again, we have the available dataset names, and I'm going to plot the C10 channel. And I'm just going to use Cartopy commands for this. The only thing that we need to do in SatPy is to convert the coordinate reference system. And for that, we have this very handy toCartopy CRS method, which will just create a CRS for Cartopy. And once this is done, then we can just use regular Cartopy commands, matplotlib commands, and then we get this plot here. And in this case, it shows the temperatures in Kelvin with the bar on the right. And exactly in the same fashion, you can also do the same for the resampled. So it will use data that has been resampled and then show it here on screen. So it's a bit small, but the data is there off the coast of the Caribbean there. And yes, I still have 2 minutes maybe. So I just want to show the last thing probably is that the commands that you use now for ABI, for GOES, work exactly the same way for other satellites. And in this case, I'm going to take polar data, so low Earth orbiting satellite data from SUMI and PP. And I create the scene in the same way. I provide the name of the files here. I just specify another reader. And then I load the true color, I load the cloud face, for example. I resample it on my area for Germany. And then I show it on screen. So after a few seconds, it will show the plot. It will show the image on the screen, resampled over Germany. And I put also the coastlines like this. And that's what I had. Thank you. Any questions? Preguntas?
Thank you very much, Martin. Do we have any other questions? I do not see any other questions in the chat window. So let's do this. I think some of us in this group already use SatPy or are using SatPy for in our institutions. So let's quickly show what we have done with SatPy or Pytroll. Let me begin. I'm just sharing here with you some plots that I have created in the past using SatPy, especially for Meteosat, because Severi, as you may see here on these plots, the Severi sensor covers a good portion of Brazil. So we have a good user base, especially in the Brazilian Northeast. So we have here some examples, plot examples for Meteosat, Sentinel-2 and Sentinel-3. And as Martin shown, these are produced using only a few lines of code. Let me find here right? I loaded the readers and the composite readers for the OG sensor in this case, and the RGB. Also, for DSET, which is our main visualization interface that we use here at NPay in Brazil, this is the interface. We have used some functions from SatPy, especially for the TrueColor composite, which we are seeing here. So yes, here in Brazil, we have used SatPy, and it's a great and very useful tool. So now I would like to open for other members of this task force to present what they are doing with SatPy. And I think we have some colleagues from Mexico and Guatemala who have created some imagery with SatPy. So I would like to invite Alejandro Sierra. In a couple of minutes, Alejandro, you may share your screen and show what you are doing with SatPy. Please share your screen.
Sorry. How do I share my screen here?
Oh, just a moment. I think Marcial, can you please change the privileges for the presenter, give presenter privileges for Alejandro and Mario Guerra. I wonder if Marcial is there. Let's wait a little bit. Okay. If he's not, let me check if I can do that. I can't do that. So Marcial is not available there, but he will return in a few minutes. So while he is not available, let's move on, and I will talk a little bit about the GLM, and then we proceed with your demonstrations, okay, Alejandro and Marcial. Oh, Alejandro sent a link in the chat window. Do you want me to show it?
Yes, please show it, and I will in a minute explain it, please.
Okay, just a moment. I will share my screen again. And here it is, a very nice animation. Can you see it?
Yes, we use a PySat for the TrueColor also to create this. I was doing that with my own program in C, but I was not solved the problem of Rayleigh correction. So I prefer to use right now PySat. My own software in C is faster, much faster, but I don't like the result without the Rayleigh correction. So I use PySat. But yes, we use a lot. We especially I want to promote the use of high quality open source code. So we use a lot of open source code in our lab. And this is just an example. The other, I did it with my own program. Thank you.
Thank you very much, Alejandro. Muchas gracias, Alejandro. Y también our colleague from Guatemala, Mario Guerra, compartió, he shared a link with some imagery created by him using SatPy. Mario también compartió algunas imágenes generadas por él usando SatPy.
Hi, can you guys hear me all right?
Yes.
Well, yeah, I'm so sorry, I was not ready to actually like present some of my things. SatPy currently, as we're using it, is very useful. Firstly, because I'm very much a beginner when it comes to coding in general, and I don't have much like background on it, but I do. It is like a very useful thing for us to have here at the Meteorology Institute that I work in currently. And the way that we're using it right now is for products that are being updated sort of in real time every 10 minutes, because you know that's how often GOES 16 images are being updated. And right now I'm using it mainly for products that include lightning mapper sort of events and flashes and the such. And It's been a really useful tool for me because when I started working here, I was just a beginner in Python and all of these things, and it was incredibly easy for me to figure out using the documentation that you guys have provided, and it's an awesome tool that I want to teach everybody in the institute to use, because a lot of people here use satellite imagery. So that's all.
Thank you very much, Mario. Entonces, Mario comentó que él no tiene tanta experiencia así con programación y SatPy fue muy útil para él en Guatemala y están generando imágenes del GOES y del sensor GLM, y comentó también que la documentación de SatPy es muy simple y la herramienta es excelente. Muchas gracias, Mario. Thank you very much, Mario. Do we have any other comments, or any of you would like to demonstrate what you are doing with SatPy? I have a final question, Martin. Do you know if SatPy currently supports the derived products from GOES, like precipitation estimates and land surface temperature, etc.?
Okay, I'm not very familiar with those products myself, because obviously we don't use these products that much. But I know that colleagues from Canada, for example, have been working with these. So there are at least a few of the level 2 products which are available, absolutely. Maybe David knows more about this?
Yeah, I can link to the configuration file for the ABI level 2 reader, but it should be every product that's considered a NOAA level 2 product should be supported. At least the imagery type ones.
Okay, got it. Thank you, David. Entonces, David, yo le pregunté si SatPy soporta los productos de nivel 2 del nivel 2 del GOES, por ejemplo, precipitación, temperatura de superficie, etcétera, y él comentó que sí, en el reader de GOES, que están estas imágenes que pueden ser configuradas en el archivo de configuración, que estos productos también están disponibles. Excelente.
I would like to thank you all. Unfortunately, I have to leave. Okay. It is quite late for me here. So the family is waiting. But I think David can stay a bit longer, and he will be more than able to answer any questions that you might have about SatPy.
Thank you very much, Martin, for your presentation. And when you mentioned it in the beginning of your presentation that you and your colleagues, you realize that you have the same challenges and you need to use the same imagery. That's the situation here. Yes. And that's why we have created this group too. We have many things trying to do the same thing. So if we join our efforts, things would be much easier. So thank you very much for your presentation.
Thank you. And I'm looking forward to seeing you around the Pytroll Slack, maybe. Goodbye.
Goodbye. Thank you. Y acá estamos, David compartió el archivo de configuración del SatPy, donde podemos ver los productos nivel 2 del GOES. Cloud top height, cloud top temperature, cloud top phase, clear sky mask. So entonces estos productos están disponibles en SatPy también. Okay. Excelente. Let's move on. Seguimos. Un momento. Si vosotros tienen alguna pregunta sobre el SatPy, pueden enviar en el chat. Okay. If you have any other questions related to SatPy, you may send those on the chat. Now let's talk a little bit about collaborative development and the GeoLand gridded products. Vamos a hablar un poco sobre el desarrollo colaborativo que empezamos a discutir en la primera reunión y los productos GLM. After our first teleconference, as a result from an action, we have created a dedicated web page with the resources shared by this task force. Como resultado de nuestra primera teleconferencia, hemos creado una página web con los recursos compartidos por los miembros. Entonces, déjame accederla acá. Let me access it. This is it. So we have the teleconference recordings, the minutes, the presentations from each teleconference. We also have the links here to join the communication and development tools like Telegram, Discord, and GitHub. We also have the links to all the interfaces presented by our colleagues, at least those who are open for external users, right? So here we have a lot of interfaces shared by you in our first teleconference. And you also have the open source solutions shared by task force members, and we should add a link for SetPy here too. We also have, in the end of this web page, some links for the collaborative development. Entonces, en esta página tenemos las grabaciones, actas y presentaciones de las reuniones, y también tenemos los enlaces para unirse a las interfaces de comunicación y desarrollo como Telegram, Discord y GitHub. Y también tenemos los enlaces de todas las interfaces presentadas por nuestros colegas en la primera reunión, al menos las que están abiertas para el público externo. Y también tenemos las soluciones de código abierta compartidas por los miembros, como por ejemplo el paquete Python compartido por João de Perú, ¿no? Que es muy bueno y hemos usado acá también. Muchas gracias, João, por compartir. Right, and just remembering the approach suggested in our first call, and this was just a suggestion, the group may work on another way depending on what is viable and what is possible. And in this case, we have suggested that we should define some target products, as we call it, right? And we would work together in a repository with code examples. So those who want to implement these products in their own visualization interfaces, they would have a nice starting point. And after some refinement, these scripts and solutions would be shared with the general community through capacity building activities that already exist, and some of us are already involved. Entonces, recordando lo que fue sugerido en nuestra primera teleconferencia, y esto es solo una sugerencia inicial, el grupo puede trabajar de otras maneras dependiendo de lo que sea viable. Y en este caso tendríamos un producto que trabajaríamos definido por el grupo, ¿no? Y trabajaríamos juntos siempre que posible en un repositorio con ejemplos de código, para que aquellos que quieren implementar estos productos en sus propias interfaces de visualización tengan un buen punto de partida. Y después de algunos refinamientos, estos scripts y soluciones se compartirían con la comunidad en general a través de los eventos de capacitación que ya existen y que algunos de nosotros ya estamos involucrados. And as a first test, we suggested starting with the GLN gridded products, which, based on the feedback, are not that used in our region. I think only Mexico in the first teleconference mentioned that they use the gridded products like the FAT, TOE, and MFA. All the others, we are just plotting the flashes, groups, and events as lat-long points. So we have added some resources like quick guides and presentation about these, what we call the target products. We also have a link with visualization examples developed by task force members, Mexico in this case, and a link with some code examples. Y como una primera prueba, sugerimos comenzar con los productos GLM que son, por lo que hemos visto, subutilizados en nuestra región. Y en esta página web hemos añadido algunos recursos, como guías rápidas y presentaciones sobre estos productos. También tenemos un enlace con un ejemplo de visualización desarrollados por miembros del grupo, en este caso de la NUT en México. Y un enlace con algunos ejemplos de código. Well, about processing these DLM products, these are the high-level steps that have been followed initially, from checking the reference material, check if other members from the group have processed this product, search for open source tools that could help, create some preliminary plots, and making some refinements based on the feedback. Sobre el procesamiento de estos productos GLM, estos son los pasos que se han seguido inicialmente, desde verificar los materiales de referencia, ver si otros miembros del grupo han procesado este producto, buscar herramientas de código abierto que puedan ayudar, crear algunas imágenes preliminares y hacer algunos refinamientos basados en el feedback del grupo y otros expertos. So, explaining it very, very quickly, we see in the reference quick guides that the GLM datasets are produced as points of latitudes and longitudes, resulting in a loss of information concerning spatial extent. So we need to re-navigate the GLM latitudes and longitudes to a 2 per 2 kilometer ABI fixed grid And with that, it's possible to calculate the fat, TOE, and MFA products. So basically, we need to apply the gridding, calculate the fat, TOE, and MFA, making an aggregation every X minutes, and finally produce the final plots. Explicando muy rápidamente, vemos en estas guías rápidas de referencia que los datos LM son datos, los datos originales, ¿no? Son datos puntuales, con las latitudes y longitudes, lo que resulta en una pérdida de información sobre la extensión espacial del dato, por lo que debemos navegar las latitudes y longitudes de los datos GLM a la grilla o malla, no sé cómo se dice en español, del sensor ABI de 2 por 2 kilómetros, y con eso es posible calcular los productos FET, TOE y MFA. Entonces, básicamente necesitamos hacer este gridding, calcular estos productos, hacer una agregación, un acúmulo cada X minutos y finalmente graficar las informaciones. And here I just added a screenshot of the original 20-second GLM datasets. And you may see that we have the events, flashes, and groups, latitudes and longitudes. In this sample file, we have almost 7,000 events, right? Acá pusimos un pantallazo de los datos originales del GLM, donde tenemos los datasets de latitud y longitud para los eventos, flashes y grupos. Y en esta muestra específica tenemos casi 7,000 eventos. Entonces, estos son datos que debemos navegar para la referencia de 2 por 2 kilómetros del sensor ABI. ¿Y cómo hacer esto? ¿No? Este es el problema. And one of the members of this task force, Alejandro Aguilar, thank you very much, Alejandro. He's already processing these products, and he mentioned that he's using CSPP-Geo, Grid GLM package, to perform this gridding. And he will present more details later. And if you look at the description in the CSPP-Geo Grid GLM page, they mention that they are using another open package in the background called GLM Tools, right? Uno de los miembros de este grupo de trabajo, Alejandro Aguilar de México, está procesando estos productos y mencionó que está utilizando el paquete CSPP-Geo para procesar estos productos. Y Alejandro presentará más detalles más adelante, y si miras la descripción de este paquete que comentó, ellos mencionan que por detrás están usando un otro paquete llamado GLM Tools. And here we have, at this link, we have the repository for this Python package called GLM Tools. Y acá tenemos el repositorio de este paquete Python que se llama GLM Tools. And basically, this package has functions that performs these gridding procedures as described on the quick guides, and it also calculates the FAT, TOE, and MFA products, among many other features. And the script that does that is this one called make glmgrids.py, which is one of the script that we call in the code examples. Básicamente, este paquete GLM Tools tiene funciones que ya realizan estos procedimientos de gridding, ¿no? Como se describe en las guías rápidas, y también calcula los productos FAT, TOE y MFA, entre otras características. Y el script que hace eso es este que se llama make glm grids, que es el que hemos llamado en nuestros códigos de ejemplo. So if you have some 20-second GLM samples, right, as we are seeing here on the left side, it is just a matter of running this script, passing the right parameters, and it will generate those gridded files, 1 per minute, as you may see here on the right. The naming convention changes a little bit from LCFA to GLMF. And they also have inside them the datasets for the FED, MFA, and TOE. Entonces, si tienes muestras de los archivos originales del GLM a cada 20 segundos, como vemos acá a la izquierda, es solamente una cuestión de ejecutar el script makeglmgrids.py, pasando los parámetros correctos, y él generará estos nuevos productos, 1 por minuto, ya estos archivos que ya están navegados, siendo un archivo por minuto, como ven acá a la derecha. Y estos archivos tienen ya los productos calculados, FED, Minimum Flash Area y Total Energy. But usually these products are not plotted every minute. But on the examples I have seen, every 2 or every 5 or every 10 minutes to match the CONUS and the full disk scans. And this package has a function to make this aggregation easily. Por lo general, estos productos no se grafican cada minuto, sino a cada 2 o 5 o 10 minutos para que coincidan con los escaneos de conos o disco completo. Y este paquete también tiene una función para facilitar esta agregación. And here are some preliminary plots, and they look at nothing like the examples available in the internet. We are not sure about the units and color scales. Y estos fueron algunos de los gráficos preliminares que no se parecían en nada con los ejemplos en la internet. Entonces, no sabíamos exactamente sobre qué unidades y las escalas de colores que deben utilizarse. So we need to contact the experts. And thanks to Bernie Connell from CIRA and Joseph Pathan from the University of Maryland, who kindly shared some information via email, we could adjust these plots using the right units and color scales. Entonces, tuvimos que solicitar la ayuda de los expertos, y gracias a Bernie Connell de CIRA y Joseph Pathan de la Universidad de Maryland, que compartió algunas informaciones, pudimos ajustar estos plots y escalas de colores correctas. And we could produce this imagery, which is very similar to the ones in the reference material. Y pudimos producir estas imágenes que son muy semejantes a las imágenes de los materiales de referencia. Another thing we would like to do is remapping these data sets so we could overlay them with other products in the future. We had no idea how to do that with the data like the ones produced by the GLM tools package, and thanks to the Python examples shared by João from Senami, Peru, that was totally possible using the Pytroll package as demonstrated by João in his notebooks. Otra cosa que nos gustaría hacer es reproyectar estos productos para poder superponerlos con otros productos en el futuro. Y no teníamos idea de cómo hacerlo con datos como los producidos por el paquete GLM Tools. Y gracias a los ejemplos Python compartidos por João de Senami, Perú, eso fue totalmente posible usando el paquete Pyproll y los ejemplos que tienen en sus notebooks. Entonces, muchas gracias a João. And here we have an example with reprojected FED, TOE, and MFA datasets overlaid with ABI data. Y acá tenemos un ejemplo de los productos FED, TOE y MFA reproyectados superpuestos con datos del sensor ABI. And that's all. We really hope these examples that are available on the links on the webpage of this group could be useful for those who are wanting to implement these GLM products in the future. And now Alejandro will present how he is doing that. So I will, let me check if Marcial is up. Marcial, could you please make Alejandro a presenter?
Yeah. Begin the line.
I will stop sharing.
Voy que no encuentro a Alejandro en la lista. ¿Es así, no?
A Sierra.
Claro. Listo.
Go ahead,
Muchas
Alejandro.
gracias. Screen. Sure. Should I talk in English, Diego, or in Spanish?
Most participants are Spanish speakers, entonces creo que es mejor que hables en español. Entonces, David, if he has any questions, he may ask in the chat, as he has already done, and I'm answering his questions here. Entonces, creo que es mejor en español.
Sí. Bueno, desde hace tiempo recibimos de los datos directamente. Tenemos una antena para el GOES 16 y desde hace varios años generamos esta animación que es cualitativa sobre la actividad eléctrica con GLM. Usamos CONUS porque es cada 5 minutos y prácticamente todo México está incluido en CONUS. Pero recientemente cuando salieron los productos que pueden ser en español gridded products, mallados o en rejilla, ya estamos generando unas visualizaciones similares a las que mostró Diego. También falta refinar las escalas. Yo creo que una de las principales razones que mencionaste es que varía muchísimo. A veces hay mucha actividad eléctrica y a veces hay muy poca. Nosotros estamos usando nuestro propio software para reproyectar en distintas regiones de interés de acuerdo a lo que interesa a distintos usuarios de estos datos. Entonces, pues podemos ver los productos principales en rejilla, como son la necesidad de extensión de flash, la energía óptica total o el promedio de área flash en destello. Y no sé, nosotros, bueno, estamos usando, como ya mencionó Diego, el de CSPP, Gridded, no, pero solamente se ve esta pantalla, ¿verdad? Estoy mostrando otras pantallas y solamente se ve
Oh, perdón, Alejandro, solamente estamos viendo esta pantalla.
Sí, bueno.
Solo la
No
página
importa,
de la
tú ya
nota.
lo mostraste, es la CSPP GeoGridded GLM, salió en diciembre del año pasado, a finales de diciembre, la última versión, y es lo que estamos usando para generar los productos y nosotros mismos hacemos la visualización con nuestro propio software. Y bueno, aquí está la dirección desde donde pueden ver cualquiera de estos productos y se genera una animación de las últimas horas. Entonces, bueno, no sé si tengan alguna pregunta sobre cómo estamos generando estos productos. Es una combinación de software libre y nuestros propios productos de visualización. Usamos mucho GEDAL, que también ya se mencionó en una reunión anterior. Y pues software desarrollado por nosotros mismos. Entonces, pues si tienen alguna pregunta, con mucho gusto. ¿Quieren que ya detenga mi...?
No, vamos a ver si hay preguntas. ¿Tienen alguna pregunta sobre la cuestión del GLM? La idea es esta, tener al menos un punto inicial para los que desean empezar a agregar estos productos a vuestras propias interfaces de visualización. Por ejemplo, déjame compartir mi ventana otra vez. En DISA todavía no lo tenemos. Tenemos grupos y eventos, ¿no? Pero no tenemos estos productos. Mira que son datos puntuales, ¿no? Y Douglas está trabajando con los ejemplos que se han generado, está trabajando para añadir estos productos de GLM en esta herramienta también. Entonces, esta es la idea. Si alguno de vosotros desean añadir estos productos a vuestras interfaces y tienen alguna dificultad o no comprenden alguna cosa, pueden enviar mensajes por el grupo y hacer vuestras contribuciones al GitHub. Y esta es la idea, ¿no? ¿Alguna otra pregunta sobre el GLM? Bueno, muchas gracias Alejandro por las informaciones.
Con mucho gusto, cualquier duda me pueden escribir.
Ok. Bueno, entonces tenemos algunos minutitos más para discusión abierta, ¿no? Y aquí es abierto, ¿no? Sugerencias, ideas de cómo podemos trabajar, comentarios de cómo podemos, sugerencias para las próximas reuniones entre otras cosas. Entonces, si alguien tiene algún comentario, ¿verdad, Marcial? La idea es que sea un grupo colaborativo y que las cosas fluyan de modo muy dinámico. Una de las preguntas que yo tengo, ¿debemos también tratar de recepción de datos en este grupo o no? ¿Vosotros creen que solamente procesamiento? ¿Creen que sería interesante tratar de recepción también? ¿Qué creen? Dejo una pregunta en el aire.
Yo creo, al menos de mi parte, yo creo que la parte de recepción es crucial para garantizar la disponibilidad de la información, ¿verdad? Y no sé, me parece que si lo dejamos de lado, nos enfocamos solo en procesamiento y visualización, estamos descuidando el que todos tengan acceso a la información. Y en realidad hay varias formas fáciles de obtener los datos que podríamos tal vez preocuparnos por aprender primero. Y creo que tal vez no es tan difícil de hacerlo, ¿verdad? Con el AWS o con Unidata o con Threads o con las varias herramientas que existen, es fácil obtenerlo. Entonces tal vez no sea un trabajo muy pesado que podríamos decidir enfrentarnos a eso.
Ajá. Excelente. ¿Algún otro comentario sobre esto? ¿Sugerencias para las próximas reuniones? Comentarios sobre cómo podemos priorizar se dice, ¿no? Las cuestiones y los problemas y cómo proponer soluciones, cómo definir lo que es una prioridad para este grupo, qué producto sería una prioridad, podemos ayudar a todos, cómo vosotros creen que nosotros podemos trabajar. Como se comentó hoy, muchos de nosotros trabajamos en cuestiones que son muy semejantes. Y hablando en esto, yo tengo, déjame abrir otra presentación. I wonder if Richard, você está aí ainda? No creo que está. Pero bueno, déjame compartir una cosa. Esta semana, el lunes y el martes, hemos recibido en el INPE algunos colegas de una institución llamada Sensipan. Sensipan básicamente es el sistema de protección de la Amazonia, ¿no? Y entre sus atribuciones están la comunicación con los bomberos se dice, ¿no? Bomberos. Y los bomberos preguntaron, desean tener una interfaz para la visualización de datos que sean útiles para la operación, el trabajo de los bomberos, ¿no? Porque hasta un tiempo atrás solamente trabajaban en las regiones urbanas del Amazonas, pero ahora trabajan en cualquier punto y como es una región gigante y hay costos muy altos para el desplazamiento, ¿no? 2.000 kilómetros para ir y volver, entonces, en algunos casos, entonces tener informaciones satelitales para definir qué es una real necesidad o no, es clave para ellos, ¿no? Entonces, esta institución, que es de Brasil, que también es una institución del gobierno, está trabajando en este panel, que se llama panel de fuego, en portugués, ¿no? Con imágenes de satélites polares, como el Sentinel-2, como pueden ver acá, ¿no? Aquí una imagen de 10 metros de resolución de Sentinel, y acá otros puntos calientes detectados por otros satélites LEO de menor resolución, como el VIRS, por ejemplo. También tienen imágenes de las luces nocturnas, que también son muy útiles para la detección de incendios. Y lo que estamos trabajando junto, y por eso recibimos la visita de ellos, es que los bomberos han solicitado que si pudieran agregar datos a cada 10 minutos del GOES, de los compuestos RGB del GOES, también en esta interfaz, para que ellos solamente utilicen una interfaz. Y también si pueden agregar en esta interfaz datos, por ejemplo, de los vientos, como hace Windy, ¿no? Estas animaciones de los streamlines, ¿no? Y entonces hemos discutido cómo hacer esto y hemos hecho un entrenamiento y ahora están trabajando en esto. El punto que quiero llegar es que seguramente otras instituciones en otros países que se dedican a la comunicación con bomberos, por ejemplo, también están trabajando o ya han trabajado o van a trabajar en el futuro en interfaces como esta, que Sensipan está trabajando ahora mismo, ¿no? Y seguramente los problemas serán los mismos, los desafíos serán los mismos, Y entonces la idea, yo creo que en el futuro este grupo pueda servir para discusiones más temáticas, ¿no? Interfaces para bomberos con datos satelitales. Entonces invitamos instituciones en nuestros países que están trabajando con esto y intercambiamos informaciones entre nosotros, ¿no? Entonces creo que esta es una idea para el futuro, para expandir la utilidad de este grupo, ¿ok? Estoy viendo acá. ¿Algún comentario?
Yo estoy de acuerdo, me parece muy interesante lo que propones.
Entonces, si vosotros en vuestros países conocen alguna institución o instituciones que están trabajando con esto, contacto con bomberos generando imágenes satelitales para la toma de decisiones, por favor, envíenme un correo a mí a Marcial y vamos coordinando si esto es posible en el futuro y empezamos a trabajar con estas áreas más temáticas, ¿no? Temas específicos en este grupo también. Un otro detalle que me gustaría compartir con vosotros es que mi colega del INPE Douglas hoy agregó al DSAT los vientos de datos de modelo con estas animaciones como en otras interfaces. Déjame ver en otras... Un momento. Lo que quiero comentar es que para hacer esto usó también herramientas abiertas. Y si alguien quiere hacer algo semejante en vuestras instituciones, justamente la demostración no funciona. Esto suele pasar.
Nunca funcionan las demostraciones.
Nunca funciona en la demostración, pero bueno, tengo acá un ejemplo, ¿no? Entonces, Douglas está usando herramientas abiertas para esta animación que están viendo. Entonces, si están interesados en hacer esto, bueno, puede ser un tema para las próximas reuniones también, ¿ok?
Muy interesante.
Ajá. Poco a poco va mejorando la herramienta.
Diego.
Hola. Hola.
Hola, Diego. Hola, Miguel.
Hola, Miguel.
Miguel Fernández. Oye, Diego, mira, un comentario al respecto a lo que tú mencionabas sobre los bomberos. Nosotros acá sobre los bomberos, no sé, ¿me escuchas bien?
Te escucho perfectamente.
Ya, acá en Chile, nosotros cuando empezamos a trabajar en la Católica, el proyecto GEOS, una de las motivaciones que tuvimos fue justamente el tema de la CONAF, que es la Corporación Forestal en Chile, que tiene que ver con el ataque de los incendios forestales. Ellos necesitan mucho el tema del viento, de la humedad relativa, de las temperaturas y por supuesto toda la información satelital que se puede obtener referente a zonas donde hay puntos calientes o algo así. Entonces, el proyecto GEOS tiene considerado eso. Incluso hay una capa que yo no mencioné en la última reunión, que trabaja también con los tile maps para mejorar las imágenes. Esa capa o ese módulo de GEOS está funcionando, solo que nosotros no le estamos cargando por ahora imágenes satelitales a esa zona. Así que yo creo que una de las cosas que vamos a hacer, nosotros tenemos una reunión grande ya el próximo martes programada para GEOS. Vamos a ver si priorizamos esa parte de los time maps para poder incorporar estas imágenes, porque cuando nosotros trabajamos en GEO, normalmente trabajamos con el dato vivo que yo mencionaba anteriormente, o que yo puedo tomar cada uno de los puntos del mapa y procesar esos datos y obtener nuevos productos. Pero también tenemos esa opción de un módulo con las capas de time maps que las podemos poner como capa y incluir, ¿no es cierto?, con otros productos. Así que eso se está considerado en nuestro proyecto GEOS, para que si a alguien le interesa, que se ponga en contacto con nosotros a ver cómo podemos asesorarlo y cómo podemos trabajar juntos, porque como tú mencionabas en este tema de colaborativo, la idea es que muchas personas trabajen para un producto y así este producto crece y nos beneficiamos todos con él. Esa es la idea.
Excelente, muchas gracias por tus comentarios, Miguel. Y esta es la idea. Entonces, ve avisándonos qué tal va este proyecto, los datos satelitales que crean que sean interesantes y entonces intercambiamos informaciones sobre lo que están visualizando acá. Por ejemplo, datos, lo que me impresiona de este proyecto que es que están creando un mosaico. Están viendo mi pantalla, ¿verdad? Están creando un mosaico de Sentinel-2 gigante, como pueden ver acá, para todo Brasil. Y cada pedazo de este mosaico tiene 10 metros de resolución. Y estos mosaicos se actualizan a cada 5 días. Bueno, la frecuencia temporal es baja, pero en muchos casos pueden ayudar a los bomberos a detectar, por ejemplo, la dirección de cómo avanza el fuego, ¿no? Juntamente con los puntos calientes de otros satélites es una buena información. Entonces, ¿cómo están haciendo eso? ¿Cómo hacen los mosaicos? ¿De dónde sacan los datos? ¿Cómo los bomberos acceden a esa información? Etcétera, etcétera. Creo que puede ser algo interesante para hablar en estas reuniones también. Luciano está preguntando el campo de viento de GFS a qué fecha y hora corresponden. Yo voy a preguntarlo a Douglas porque tampoco sé a qué hora es. No sé si está haciendo el procesamiento de cero y luego está casando los horarios de las previsiones con los horarios GUES. Es una pregunta muy interesante. Yo voy a preguntarle, ¿dónde podemos ver? Ok, yo tampoco sé porque hoy, justamente hoy, hace un par de horas que activó esta funcionalidad. Ok, le voy a preguntar y te aviso, Lucho. Gracias. ¿Algún comentario más? Marcial, ¿algo más?
No, lo único que me gustaría es preguntarles al grupo y tal vez lo podemos discutir en el Discord o en algún otro lado. Tal vez ir como sentando algunas prioridades. Yo siento que en las áreas son muy amplias, entonces ocupamos tener como prioridades para poder decidir si algunos quieren trabajar en una cosa o si algunos se piensan más otra cosa, pues otra cosa. Pero sí siento que el poner prioridades nos serviría mucho para poder desarrollarnos. Entonces, y eso, obviamente, en las Américas hay mucha capacidad técnica, pero inclusive los resultados de las encuestas que hemos visto siempre sale como que no hay capacitaciones técnicas o que falta capacidad técnica en los lugares. Entonces, lo que quiero es como este hueco que existe entre el montón de capacidad que vemos que existe y las aplicaciones de esa capacidad en operaciones, quisiera ver cómo podemos ir cerrando ese hueco. Vamos.
¿Comentarios del grupo sobre esto? ¿Cómo priorizar los problemas e implementar las soluciones? Bueno, en todos casos podemos seguir hablando en nuestras social networks y seguir con el trabajo del grupo.
Algo que me gustaría a mí, Diego, tal vez para mencionar un poco. Yo sé que todos tenemos nuestros trabajos y yo sé que nadie quiere más carga de trabajo de la que ya tiene.
Claro.
Yo lo entiendo muy bien. Entonces, si hay algo que quiero resaltar aquí es, si organizamos esto, no tenemos por qué hacerlo de gratis y no tenemos por qué hacerlo solo voluntarios. Si organizamos un esfuerzo, entonces coordinamos con WMO o con NOAA o con alguien para conseguir fondos, para que las personas que se metan en esas tareas, pues se les sean reconocidas y se les pague por su tiempo o por sus participaciones o por sus productos o por como sea que nosotros como grupo decidamos. Pero sí quería dejarlo claro porque no quiero que se sientan como que estamos tratando de ponerles sobrecarga sin reconocer lo que se esfuerzan. Es todo lo contrario. Yo quiero más bien que nos organicemos para poder hacer eso. Porque entonces buscamos los recursos, los fondos y los aplicamos a ello.
Claro, porque hasta ahora estamos trabajando, ¿no? Lo que hemos sugerido es que algo que sea una necesidad en común, como por ejemplo, muchos quieren hacer gráficos de estos productos. Ok, vamos a trabajar juntos y bueno, lo que sea viable, ¿no? Y ahora Marcial está ya hablando de algo más, ¿no? Más estructurado, ¿verdad, Marcial? Estructurado y cuestiones de fondos, etc. Y yo creo que entonces empezamos con cosas más concretas, ¿no? Que sería muy interesante. Comentarios, sugerencias. siempre recordando que el feedback es muy importante y estamos acá para oírlos, ¿no? Y saber lo que sugieren. Entonces, teniendo esto, lo que comentó Marcial, sabiendo de estas posibilidades, bueno, vamos hablando e interactuando entre nosotros hasta la próxima reunión y con ideas más concretas y cuáles serían las posibilidades, ¿no? ¿Algún comentario más antes del final de la reunión?
Creo que ya, bueno, aquí ya es hora de almuerzo, así que me imagino que por algunos otros lugares también.
Bueno, entonces, muchas gracias. Muchas gracias a todos. Y si tienen sugerencias para nuestra próxima reunión, avísanos y invitamos a los participantes que sean necesarios. Again, I would like to thank Martin and David for their participation and their excellent presentations and demonstrations from this group. And the group is open for their collaboration from the SatPy developers and anything related to satellite imagery. So we will keep inviting you for the future teleconferences, and if you have any suggestions for the work of this group, as you see here, you have representatives from many countries. So here is if you have any updates or any new features for SatPy, this is a very nice place to spread the word. Okay, so thank you very much, and muchas gracias a todos. Hasta la próxima reunión.
Muchísimas gracias a todos los participantes. Nos vemos la próxima. Hasta luego.
Gracias.
Hasta luego.
Gracias a usted, Marcial y Diego. Un saludo. Gracias.
Hasta luego.
Thanks.